Hi there, Good Golf here with a new video. As part of the series on how to create a survival game, this video starts with the basic code for procedural terrain generation. For now, this will be a single-player version of the code. I will prepare it for networking support, but the actual fishnet networking support will be added later. The code will be available in the GitHub repo so you can play around with it. Okay, let's start with the basics. What is procedural terrain generation? Procedural terrain generation is the algorithmic creation of digital landscapes, mountains, valleys, plains, using code and mathematical functions rather than manual modeling. It utilizes algorithms, often based on noise functions like Perlin or simplex noise, to generate random yet natural-looking large-scale or even infinite environments in real time. While some survival games like Enshrouded use a hand-modeled terrain, many other survival games use a terrain which is created using a seed number which always generates the same terrain for the same number. This deterministic approach will help us later when we want to network enable the terrain. We want each client to create its own terrain, exactly the same, instead of streaming all the terrain data across the network. Also, we want to stream terrain, so we create a terrain stream controller which loads and unloads terrain in a multi-terrain setup, depending on how close these terrains are to the player. This requires us to create the terrains seamlessly. Last, we don't want dull terrain landscapes, so I will also add biomes. So, mountains at higher elevations will look different from plains at lower elevations. Each of these features can be tweaked in the settings. What does this first version include? As I stated before, I prepared it for multiplayer, but fishnet support is not included yet. For performance reasons, I converted it to jobs and burst, since changing height maps requires a lot of calculations, and we don't want the game to pause for seconds whenever a new terrain chunk needs to be loaded. These calculations can be done in parallel, so a conversion to jobs makes a lot of sense. I also included a script which allows you to put objects on the terrain, again deterministic, after a chunk has been generated. Details and trees will come in a later version. Let's look at the classes used to stream and generate terrain in this code. The terrain streaming controller is the code which manages the multiple terrains. It will load terrains close to the player and unloads terrains when the player moves out of range. When loading a new terrain, it uses a terrain prefab and copies all settings, including the splat layers. It uses a terrain data pool to prevent performance issues when creating terrain data for each new terrain. Once a new terrain chunk is created by the streaming controller, the streaming terrain generator jobs version, which obviously uses burst and jobs, will run terrain height jobs in parallel. The math used for calculating height jobs can be run in parallel, so I changed the code into jobs and the performance jumped up. I also added a terrain prefab placer, which reads a scriptable object containing the list of game objects and how they should be placed on top of the terrain. Objects can be rotated, and for building type objects the terrain can be raised to provide a foundation. This last option cannot be performed close to the terrain seams, because that would create visible gaps at the terrain boundaries. As a bonus feature, let me explain how I got to the point shown at the start of the video, adding the splat maps. First of all, you will need MicroSplat and a separate procedural texture module. Once imported into the project, start adding terrain textures to the terrain prefab. Once you have these textures added, add MicroSplat to the terrain prefab and enable it with the button. Last, change the shader settings to have textures automatically added for each biome. You can also enable other MicroSplat features such as global snow or lava flows. This is a short introduction to the code, which can get you started exploring how it all works. I uploaded a package for Unity 6, which you can use to test the current version. Parts of this code will probably evolve, so I didn't go into too much detail. Again, I included a quick and dirty character controller, since I cannot include assets from the store in a package uploaded to GitHub. Okay, that's it for this work in progress video. Next up are some refinements and beginning the prep work for integration of both the build system and procedural terrain generation with fishnet networking. If you like this video, then please give it a thumbs up, and I will be back with a new episode soon.